Hello, everybody. Okay, good. We are online. Okay. Hi, everybody. My name is John KUTAY. I'm head of products at STRIIM. Very excited to introduce KJARTAN, MALTHE-SÖRENSSEN. We'll go through our talk today. Thank you for joining. From sensors to streams, A-ENERGI'S real-time monitoring and telemetry from a massive grid. Now, before we get started, I just want to get a show of hands. How many of you are doing data streaming today? Using tools like Apache Kafka. Great. How many of you are working with IoT sensor data? Great, great. And how many of you are working generally in the analytics space? Okay, almost all of you. Excellent. So this is very relevant. Now, as we get into this, really we're talking about how we're unifying data in real time with streams, because siloed data can negatively impact operations. Today we're focusing from the perspective of an energy company. When data is spread across your billing, application, web traffic, CRM, customer loyalty, your SCADA systems, and you have latency between those upstream operational systems and your data lake, it can lead to time wasted reconciling data, poor forecasting of all your infrastructure, lack of understanding of your customer expectations and needs, and ultimately poor customer experiences. Now today we're going to go over a real world example of going from raw operational data, whether it's that IoT sensor data, database from your data from your CRM, your SCADA system, pushing it through a streaming product like STRIIM that has IoT streaming connectors, database change data capture, streaming SQL and ETL, and ultimately you want the output of this to be data products. Now, what is a data product? That's the idea of having a data set with a SLA around the freshness, the quality, someone's job to maintain the accuracy of the data, right? Because as you have data accumulating in your lake, you don't want it to be unstructured and unusable for the business. You want data products that can drive customer experiences, whether it's better cost-effective services or increasing customer satisfaction scores, or as we're going to talk about today, real-time back-end operations such as predictive maintenance and understanding your production environment. So without further ado, I'll hand it over to KJARTAN MALTHE-SÖRENSSEN. He's an expert data practitioner who works at A-ENERGI as a senior data engineering leader. Lots of experience. Without further ado, I'll hand it over to you, KJARTAN.
Thank you. Yeah, my name is KJARTAN MALTHE-SÖRENSSEN. I work for A-ENERGI. I'm a senior data engineer, solution architect. I spent a number of years as a consultant, as an Oracle expert. Then moving into telecom, working as a solution architect and database developer, and now lastly at A-ENERGI, working as an architect and data engineer. 44 years, married, 2 boys. I live and work in Drammen, Norway. And yeah, a little bit about A-ENERGI. We are Norway's biggest energy utility with operations throughout the value chain, from generation to end users. We have 72 hydropower plants producing 11.3 terawatts hours of clean energy. We operate and manage a grid connecting 320 end customers and retailing power to 240,000 customers. And we manage and operate at the professional market 23 terawatts hours. Our grid is consisting of 30,000 kilometers of lines and millions of components. And a little bit about the landscape. We have quite a few Oracle sources, on-prem SQL sources, legacy databases, systems. We have targets both on-prem and quite a big presence in Azure. We've started building a real-time unified data integration using STRIIM and stream data from our on-prem to Azure with STRIIM apps. And currently we stream roughly about 4 million events per day. Our biggest use cases for STRIIM and streaming data is that we we really wanted to build a real-time data integration, especially from our legacy and specialized systems. We have our network inventory systems, we have ERP systems, we have billing and invoicing systems, customers systems, and most importantly, we have our operational systems, SCADA systems. Especially the last part, we wanted to access the information from the grid and the hydro plants and any incidents that occur in real time or as soon as possible. The driving factors were to monitor both the grid and also the hydropower plants. So, and a big cost driver is predictive maintenance. I'll get back more into that. So we would use the STRIIM's capability to place an agent near the operational systems, near the SCADA systems, and use C2C and build STRIIM apps to stream the events from the SCADA systems, and then obviously combine with both IoT, generalized IoT devices, and general public sources. Combine all this data together with the SCADA information, build reports, build dashboards, and get an insight in both the grid operation and also in the hydropower plant operation and maintenance. Quick example, just an event log from a hydropower station showing turbines going on and off, sluices opening and regulating the flow of water. This is part of the dashboards, and the hydro plant operators, they can keep track of how the power plant is doing or any alerts. The most interesting part is we're currently working on getting a real-time flow of the grid. So visualizing the flow of energy, the current and the voltage, and any transformer in the grid. So you can access and see where it's connected, where the current is flowing. You can see the current voltage, and see the current load on any distribution transformer in the grid, and see how it compares, and you can see it more or less real time. Also we are this allows us to know the status of critical components, we then combine the data, as I said, from SCADA and IoT system, work orders, and combine it, stream the data from our legacy ERP systems, work orders, etc., so that we can bring everything in to one view, basically. And just a little bit more about predictive maintenance. We can build, we can show the number of incidents, what kind of incidents is affecting our grid, what's causing outage, what's causing downtime, or what's causing any grid switches, high voltage switches. All of these require regular service, so the traditional way is to do a round robin every year to service to make sure that none of these high voltage switches are basically due to welded shut due to a power arc, power surge in the area last year. So by knowing which switches has actually been used in the past year, how many times it's been used, we can target the service specifically to these components rather than visiting the entire grid once a year, all year, every year. And this is going to save all the grid planners and maintenance planners quite a lot of work. Another example is quite interesting. We're being in Norway, a bit colder during the winter, and with a lot of hydropower. Traditional Norwegian home is heated by electricity. During the winter, obviously drives need for power up. But with the massive rollout of electric cars, we see additional heavy strain on our grid. Getting an overview, using the consumption data along with the SCADA data, all in real time, we can see what hotspots are in the local distribution net. We can dimension our transformers, see which ones are overloaded, how much they're overloaded, what time of year. Interesting fact here is during the winter we can actually take quite a lot more than 100% overload due to the air cooling, simply because it's minus 10, 15 degrees. But during the summer such a load is unacceptable and the transformer needs to be upgraded. So we combine all this data from our CDC sources. We combine it with weather temperature data in particular, but also hydrology data. And based on this, the grid planners can go out, identify hotspots, and use this to actively build and reinforce our grid. And all of this has helped us moving towards more real-time, away from traditional ETL, ELT, and driving towards event-driven architecture. So very simple. STRIIM, use C2C, get a unified data integration, stream the raw data to our data warehouse, data storage, apply transformation using dbt, Azure Data Factory, Synapse, and provide real data. And we're also moving into publish, subscribe for notifying applications and consumers of data when any rows of interest are passing through. So a few challenges that we've solved using STRIIM. Simple universal time versus local time and daylight saving times. Using STRIIM's capability to do real-time querying and transformation, we converted it simply into a string and added the time zone information that we knew for that particular component, and let it implicitly be applied. We also have various version or multiple versions, especially from our grid consumption data. Whenever a meter goes offline, you can actually resend the entire week's worth of consumption events. So we get a lot of duplicates that needs to be handled. STRIIM's exception handling takes care of this. Sometimes we also have errors in the data reading, so they go and reset a meter, causing the entire buffer to resend again, but now with different values. So you go from an insert to an actually update, and with STRIIM's help we extended STRIIM's with a Java plugin and converted the insert into an update, taking care of the latest value. And as I mentioned earlier, access to secure subnets using STRIIM's agent, and then allowing only outbound communication, and the agent communicates securely and encrypts the data flowing between the node and the agent. And yeah, I think that's it from me. And over to you, John.
Yeah, big round of applause for KJARTAN. That was a great presentation from a real-world use case of monitoring lots of data from a massive grid. I'll just get into some of the key stream processing platform components that can be leveraged here. So starting with data connectors, right? We start with change data capture, going against the write-ahead logs of the databases, networking with MQTT protocols from IoT sensors, Kafka, log files, getting the data streaming with continuous data collection, thank you, into your target systems, whether it's a database or warehouse, a data lake, something like Databricks, and being able to do continuous querying. As KJARTAN mentioned, there's always these edge cases where you're going to need to transform the data in the streaming layer, such as resolving issues with timestamps. I'm sure everyone who's ever worked in data engineering has had issues with converting UTC to local time, things along those lines. Being able to capture and transform that in real time is extremely valuable, so you're not putting wasteful data in the lake, and able to actually do anomaly detection and pattern matching as well. Being able to join the data in the streams allows you to build that real-time data model, and I'll talk about how you can use that to reduce costs by ranges of 50% to 98% in the next slide. But essentially, by catching these issues in real time in the stream before you have corrupt data reaching your data lake, you're able to better adopt machine learning capabilities and build out those data models, both with ELT, whether you're using DBT or a transformation tool like Azure Data Factory in your warehouse, or if you're doing the in-stream processing to transform the data into more of the discrete models. So one of the main use cases that we see across all our industries, everyone who's trying to work in analytics, is before they start working with STRIIM, they generally have, due to the ELT layer, high costs, right? You're paying for every single row that you're ingesting from your operational database, your SaaS applications. As data comes in, you always have to rerun all your jobs, basically reconstruct your data warehouse, which reduces your availability to deliver fresh data. So the output of this is stale data that's going into your data apps, your reports, and in the future AI models when you're doing inference. You don't want stale data going into AI, right? Especially when it's making decisions from the data. And also you don't want stale data in your production data products. I mean, if you're doing real world use cases like predictive maintenance, right? You want accurate, fresh data there. Now, after STRIIM's introduced, we generally see 50% cost reduction just on the ELT side with our pricing model. We also did a benchmark with the Snowflake product team where we demonstrated 98% cost reduction just in the ingest layer. So your data warehousing bill goes down as well. So immediately, not only do you get 50 to 98% cost reduction, you get real-time data feeding your reports, you get real-time data models, ultimately better ROI, not just from cost reduction, but being able to deliver your data products with stronger SLAs, giving your data teams more leverage over freshness, quality, being able to transform the data for these edge cases. Now, how does STRIIM work behind the covers? We're going to do a demo here in our booth. You can see it's right here, STRIIM, where we have, it says real-time data for generative AI. But basically, it's a fault-tolerant stream processing engine that runs as a fully managed service. You have this concept of streaming SQL pipelines, and you see these DGs here. DG stands for deployment group. That gives you compute separation. So when you have more critical workloads that you want to dedicate resources to, so that when, let's say, one of your SCADA systems goes down, or you lose a connection to an IoT stream, you don't want to bring down your whole cluster, you don't want to bring down all your data models. The compute separation allows you that type of flexibility. Now, let's say in the worst case scenario, your primary region goes down. It's unlikely. I don't want to scare anybody thinking that their cloud provider is going to go down. But it can happen, right? AWS has outages. They just had one last week. Going from your primary to your backup with minimal downtime because of how STRIIM replicates the metadata and checkpoints the stream processing data from the source. So that also gives you the capability of having automated failover, cross-region availability, a mesh network topology, and this is all as a fully managed service. All you're doing is clicking buttons and writing streaming SQL, and you have access to all these components. You also get secure, dedicated networking for data streaming, so you have ability to build private enterprise networks, whether you're going cross-cloud, on-prem to cloud, from device to cloud. You don't need any data touching the public internet in those cases. So that's one of the components you get there. I would give a demo here, but we're going to do it in the booth instead. But really the best way to do it is go try it yourself for free. You can use our free forever tier if you scan this. It'll give you a link to that. We also have free certifications for data streaming and generative AI with our platform. Zero money down, no credit card required. You can actually go get the certification. And we even have users using our free tier as a cloud service. Depending on your SLAs, it can be a great fit. We're also able to scale out through our cloud service if you need uptime SLAs and enterprise security. Now, if you want to follow along with the work that I do in my spare time, I love speaking to expert data practitioners like KJARTAN. We have this show called What's New in Data, available on all your podcasting channels, whether it's Apple, Spotify, Google Podcasts, Amazon Music. We just did this live session in San Francisco with Sanjeev Mohan. Sanjeev is around here. Say hey to him if you see him. But if you follow along here, you'll see all our episodes. We've also had Jamak Deghani, who's the creator of Data Mesh. Lots of people talking about Data Mesh here today. I'm also interested to see, what everyone else in the community is talking about. So do follow along. Do stay in touch with STRIIM. I'll be right here in our booth. We'll give a live demo at noon there. And once again, round of applause for KJARTAN. Thank you. Thank you to everyone who attended today.
Thank you.